Welcome to the class Linear Integrated Circuit. Today we are going to see the open loop and closed loop configuration of inverting amplifier. So inverting amplifier can be used in both the open loop and the closed loop. Let's see the open loop inverting amplifier. So this is the open loop inverting amplifier, and minus, and this is V out. So inverting amplifier, if it is called inverting amplifier, we will be giving the input voltage in the inverting terminal, and the non-inverting terminal will be grounded. So this is V output, this is V out, and supply will be given here Vs plus and Vs minus. So the output voltage can be calculated. We know the voltage gain formula. Voltage gain is equal to V out divided by V in. Yes, so we need V out. So V out is equal to AV into V in. So here V in is nothing but V plus the difference between the difference of our input voltage will be amplified in generally Opamp. So V plus minus V minus. So here V plus is grounded, that is a non-inverting terminal is grounded, so it is 0. So that is equal to minus V minus. So you will get V out is equal to AV into V minus. There is a minus, you put it here. So V out is equal to minus of voltage gain, that is open loop voltage gain, into V minus. So input voltage, that is V minus, is nothing but input voltage. So this minus refers that, so it refers the phase shift of inputs with respect to the input signal. So whatever the input, so we are giving the input side, that will be 180 degree phase shifted in the output side. That is, so here output you will get exactly 180 degree phase shifted output. So that refers this minus sign. So in generally, so suppose I am giving the 1 millivolt, for example I am giving 1 millivolt input supply. So in ideal Opamp the gain will be in the order of 10 power 5. So you apply here, you calculate V out. So V out is equal to what you will get. V out is equal to AV 10 power 5 into 1 millivolt 10 power minus 3 10 power minus 3. So you will get 100 volt. You will get the 100 volt. Yes, if the gain is high, accordingly you will get the voltage, high voltage. But in generally you won't get the 100 volt and all. So it will depends on the supply voltage given to this Opamp. So as we have seen, your transfer characteristics will be like this. So it will be saturated. This is V S plus and this is Vs minus. so it will be saturated depending on the this source external voltage what we have given to the Opamp. So this is the linear region, so the output varies linearly, so with respect to input. So we need to make this Opamp to operate in the linear region, this region, to in order to use this Opamp as an amplifier. Let's go for closed loop inverting amplifier. So the open loop Opamp is we know the output will not be stable in open loop, so we are going to control, in order to control the gain of the Opamp, we are going for the closed loop operational amplifier. So let's see the closed loop inverting operational amplifier. So this is the closed loop inverting amplifier. Whatever the input we have given in the input side, it will be amplified and we'll be getting in output side. So if the any feedback, that is any path from the output to the input, that is called a feedback. So here there is an feedback with resistance RF connected to inverting terminal. So the inverting Opamp is, it amplifies and inverts the input voltage, and non-inverting input is determined by both voltage input and the output. The polarity of the input voltage is opposite, as we have seen, to that of the input voltage. Voltage input is connected to the inverting input. Here see it is connected to inverting input, and voltage input is connected to inverting input through feedback resistor, and non-inverting input is grounded. So this is the setup of closed loop inverting operational amplifier. So we will see how to calculate the gain of inverting amplifier. This is this closed loop inverting amplifier. So let's derive the gain of this inverting amplifier. As we have seen the diagram, this is non-inverting input, this is inverting input, and this is V out. So input is given to inverting input terminal, grounded, and it is given to inverting input terminal through a resistor R1, and it is the output is fed back to the input through the resistor RF. This is RF and this is R1, and non-inverting terminal is grounded. So this is the closed loop inverting amplifier setup. So in the ideal Opamp, we know that the input resistance Ri is infinity. So before getting into this derivation of a closed loop operational amplifier, we know what is a virtual short. So virtual short is nothing but, so whatever the input is given in the one terminal, that will appear in the other terminal. It is not a short circuit, but virtually it is a short circuited. So consider this is the Vx point, Vx node. So this is a current I1, and this is the current and this is the current IF. So in the ideal Opamp, in the resistance, input resistance in infinity, so the current flow through this inverting terminal is 0. So here I1 is equal to IF. So find out I1 and IF. So I is equal to, generally we we refer that V by I is equal to V divided by R. So here V is, it is connected between two nodes. This is V in. So find out the I1. So I1 is nothing but V in minus Vx divided by R1. So find out IF. So IF is nothing but Vx this input, this node, and minus V out wait a minute. V out divided by RF. So the here the non-inverting terminal is grounded, so there is no voltage to this non-inverting terminal. It is 0. So it is we have assumed it is a virtual short, so the same voltage appear in this node, so Vx will be 0. So apply this Vx is equal to 0 to this equation. You will get V in minus 0 divided by R1 is equal to Vx is 0 minus V out divided by RF. So simplify this, you will get V in divided by R1 is equal to minus V naught divided by RF. So we know that voltage gain is nothing but V out by V in. So voltage gain is equal to, V out, this is equal to V out by V in. So rearrange equation accordingly, you will get, so minus RF divided by R1. So that is close to voltage gain ACL is equal to minus RF divided by R1. So we can control the gain, closed loop gain of this inverting amplifier by using the feedback resistor RF and the input resistor R1. So accordingly, suppose we want to design for a particular gain of this amplifier, you can selecting appropriate value of RF and R1, we can design a particular Opamp that we need. So here then this negative sign indicates that, so the output will be the inverting of input signal. That is why it is called as inverting operational amplifier. If for example I am giving here input is 1 volt, that is the 1 volt of input signal, RF is 2 kilo ohm, and R1 is 1 kilo ohm. So find out the gain is minus RF by R1, so 2 by 1 is equal to 2 kilo ohm, that is 2, gain will be 2. So we know what is V out, so V out is equal to gain is 2 into V in. So V in is 1 volt. So V out you will get 2 volt. So we have given input 1 volt, that is amplified, and we are getting the output at 2 volt. So the output input is amplified and it is inverted. The inverted in the negative sign refers the inversion. So in the next class we will see the non-inverting closed loop and open loop Opamp configuration. Thank you.